Hello, class. I wanted to do this tutorial to help you with the week one formative assessment. So here on your home page, so we can go to home, and then you want to scroll down to, this is going to show you your modules, links to your modules, but you want to go to the week one formative assessment. You want to click on that, and it's going to bring you to the assessment. This is the lab portion of the course. Okay, and so here are some instructions for what you will be doing for this particular lab. It's the basic instructions actually for each of the assessments. But here, this Word file, this you want to click on and it's going to download it. Okay. And so it does come in as a pop-up. And so you want to make sure that you enable pop-ups on your device that you're using to do your assignments. And so it's going to come up and you will have the information for your week one assignment. Right. And so I like to view it in as one page. To me, it's a little less confusing. Okay. So you would just view, click on one page, and then 100%. Right. And so if you look at this, this has your instructions on what you want to do. And so these are the same instructions that you'll see for each of the labs, the basic instructions. I'll let you read through those. All right. And so what you want to do for this particular lab is you're working on three parts. The first part is significant figures. And so when we're working with significant figures, these are the rules that we use to round numbers in calculations. And so that when you put a calculation in your calculator, you know where to stop with the numbers. Okay. Because if you have this long number, like, for example, if you have this long number, 2.0000999, in your calculator, you don't want to have to write all those numbers down for your answer. So these rules are going to help you know that maybe for this particular calculation, you can round to 2.00 because you only need three significant figures for your answer. And so here are the rules. So the first rule is all non-zero numbers are considered significant unless it's ruled out. Example, the number 333.3 has four significant figures. All of those numbers are significant. There's no zeros. And when we're talking about significant figures, keep in mind this does not mean that these numbers are not important for the calculation. It simply is a way that we use in order to know how to round our final answer. The next rule, all zeros between two significant figures are significant. Example, 303 has three significant figures because that zero's in between two non-zero numbers. I like to call these the sandwich zeros because they're sandwiched in between non-zero numbers. And it doesn't matter how many zeros are sandwiched, okay? You could have 10 zeros sandwiched between two non-zero numbers. They're still going to be significant because you have two non-zero numbers on either side, okay? And then the next rule, excuse me, all final zeros in a number is only significant if it's part of a decimal. So example, 3.30 has three significant figures. Sorry about that. Because that zero's at the end and there's a decimal present in the number. When doing calculations, you must cut and round all numbers to the lowest number of significant figures. And so if you're doing multiplication or division, those are the two most um, those are the two calculations that we do the most here in chemistry. Then you're counting the number of significant figures for each number, and then you go at the lowest. Because 4.01 and 3.01 both have the same number of significant figures, which is 3, then your final answer would have 3. But say, for example, you have 5.799099383 times 3.01. This has 1, 2, 3, 4, 5, 6, 7, 8, 9. That has 9 significant figures. That zero, remember, is significant because it's sandwiched between the two nines. And then 3.01 has 3 significant figures. You always want to go with the lowest, which would be 3 significant figures. So if you put this into your calculator, your final answer, you're going to round to 3 significant figures, right? And with rounding, okay, you learned rounding at some point, hopefully, in your career. If you have questions on how to round, let me know. Send me an email and let me know. All right. And so after you've gone through the instructions or the background information for each of these parts, then there are some applications. So these are questions and examples that you can go through. For each of these, very important that you answer each question, okay? For this particular lab, I grade on completion, okay? And if I see that there are some struggles that you're having with doing the calculations or with doing significant figures, then I will leave comments about that. But otherwise, for this particular lab, I am grading on completion. So it's very important that you complete the entire lab. There's quite a few of these different examples and applications that you need to fill in, okay? Then we go to part two. Part two is the factor label method. With this is showing you how we set up problems to do our calculations. We do it by canceling out the labels or the factors that are associated with each of our numbers. Because with chemistry, our measurements not only include the number, but they also include the unit. And the unit is very important because it tells us what that particular number represents. So things like pounds, things like feet, grams, milliliters, miles, gallons, those are all units, and they play a huge part in all of our measurements. And so when we're setting up problems, okay, so for example, we have 2 feet times 2 feet. We're going to multiply the numbers. We're also going to multiply the units. So 2 times 2 will give us 4. Feet times feet will give us feet squared. And so those units, if we're multiplying them, then we're going to increase the power. If we're dividing them, sometimes they cancel out if they are the same unit. And so we this goes through some information on how we're looking at those particular units. But I want to go through this problem right here, this example problem, so you can see what we're looking at when we're canceling out units and getting to new units. And so it says the density of ice is 0.917 grams per milliliter, and we want to know how many milliliters are in 10 grams of water, okay? And so we start with our 10 grams of water, and then we're going to multiply it, and this is in the form of ice, so this is a solid form of water, times a milliliter over 0.917 grams of water ice, okay? And so we look at a few things when we're doing these types of calculations. We are starting with grams, okay? And we want to get to milliliters. So what you start with, that same unit will go on the bottom. And so we know that 0.91 grams is how many grams we have, and we know that's equivalent to 1 milliliter. And so the grams of water ice are going to cancel out because whatever unit is at the top and at the bottom, if they are the same, they cancel out, okay? Only if they're the same unit. If they are different units, we can't cancel those out. All right, so if they're the same unit, we cancel it out, and then we take 10 divided by 0.917. The 10, we are not looking at that for significant figures, okay? Say, for example, it was 10.0. Okay, then we would look at that for significant figures. But generally, what we start with is going to be a number that has a decimal, and it's going to have generally three significant figures, but it could change. So we go with the number at the bottom, 0.917, that has three significant figures. So your answer will have three significant figures because we're not only looking at the calculation, we're also looking at the significant figures and we're looking at the units, okay? And so there are three things that are involved when we're doing problems in chemistry, okay? So there are some apply and solve, so that'll give you some chances to do some calculations as well so that you can apply what you've just learned. Let me know if you have questions on how to set up these problems or if you have questions on doing the calculations themselves. The third part is moles. Okay, and so moles is a measurement in chemistry that helps us to understand very small things like molecules and atoms. Okay, and so when we're looking at the mole, there is this number which is known as Avogadro's number, and its 1 mole is equal to 6.02 times 10 to the 23rd things. And so when we talk about the word things, things can represent a lot. And so if we're looking at chemical elements, then it represents atoms. If we're talking about chemical compounds, it represents molecules, but it can also represent other things, as you'll see as you're going through the different problems for this part. But I do want to show you an example so you know how to set up your problem, okay? And so you have 100.0 grams of silver, and you want to find how many moles of silver you have. And so this number came from the periodic table, which you have a periodic table within the classroom itself. You have access to a periodic table. There also, if you Google periodic table, you'll see a periodic table pop up. Okay. But silver has the symbol Ag. And if you look in the periodic table, the bottom number is known as the mass number, and that is the number of grams of silver. And that's true for every element in the periodic table. So that's the number of grams in 1 mole. So because we're starting with grams, we want grams to go to the bottom. And remember, if we have the same unit on the top and the bottom, we can cross it out. And then we have moles at the top. So if we take 100.0 divided by 107.86, we get 0.927 moles of silver. So remember, we're looking at a few things when we're doing these calculations. We want to set up the problem correctly. We want to do the division or the multiplication. When we are doing the calculation itself, we're looking at significant figures. So 100.0, if we look at that, these three zeros are at the end, but because that decimal is there, that makes all three of those zeros significant. So it gives us a total of four significant figures. 107.86 has 5. That 0 is in between the 1 and the 7, a sandwich 0, so that makes it significant, giving us 5 significant figures. So remember, we want to go with the lowest. So 100.0 has 4, 107.86 has 5. So our final answer should have 4 significant figures because we're going with the lowest. So this is not correct. So we have 100.0. If we divide it by 107.86, we get 0.9271. Okay, so that should be a 1. And that will give us the 4 significant figures that we need for this problem. Okay. And then there are some chances for you to practice what you just learned. Okay. If you have questions, the one thing down here that might be a little confusing, it says next describe any item you have in the world in terms of moles. And so that is just to let you know that Avogadro's number applies to any object and it's equal to moles. So for example, if you have $10 in your pocket, um one mole is 6.02 times 10 to the 23rd dollars. Okay. And so that unit, remember when I said that Avogadro's number is things, the things could be dollars in this case. Okay. So if you have questions as you're going through the lab, let me know. Have a great day.